Good morning, everybody, and welcome at this first remote, shall we say, social distancing meeting on Apex. I hope you'll enjoy it. The reason we are having this session today and many more to come is essentially it's an extension to the sessions that we've started having via email on little tips and tricks in Apex. Specifically, we started with the other products as well, but the heavy focus on Apex, since this is the future platform for all the MSC technologies, and it has a lot of hidden features and many multi-purpose tools, which makes it a bit difficult to pick up on other users for the same tool, as we are so accustomed to having one tool for one function. In Apex, it works much differently. You can do many things with one tool, and because of that, not many people know that. So I want to start off, and I'll just need to switch the broadcast to my monitor. Okay, and the first thing I want to get into, especially for those of you who have indicated that you haven't used Apex before, I see there's quite a number of you. More than half of the attendees have been using Apex for well, it's actually 3/4 of you have used Apex for less than a year, with a full quarter having not used it before. So very welcome on you guys that are new to Apex, but we are going to jump in a number of advanced features quite rapidly. So for those of you who haven't used Apex before, once you open Apex, I would recommend you opening the Getting Started guide. This opens the documentation with nice intro videos, and I can recommend spending 20 minutes to go through all these videos on this page. They're not that long, and they show you a lot of the hidden features that one don't necessarily pick up by just exploring the user interface on your own. I have essentially 4 examples that I've brought along. So firstly, we will discuss a broken Creo file. That's a CAD format that I had some challenges with, and I've thought that it would be a good example to show you what to do when things go wrong and how you can work around it. The next example is on a piece of CAD geometry that's got a lot of vertices, which affects the meshing quite a bit, and I'll show you how to deal with that. Then there's an interesting piece that I had a big challenge on defeaturing for X-meshing purposes, and I'll gladly share a few tricks on that one. And then lastly, a boolean partitioning that failed. Before I jump into that, however, there is 1 or 2 videos that I just want to show you as a, let's call it a teaser of technology that is to come. So if you are aware of Adams as a standalone product in the MSC suite of products, this is one of the products that will be incorporated onto the Apex platform. And that is why I thought, you know, there's a lot of wealth in the Apex modeling foundation that you would actually need to use these various products. Another one that is coming out soon is generative design, and this is the ability to create topology optimized structures but using stress-based method, as well as being immediately 3D printable. So this new technology that MSC has incorporated has the ability to take the rules of manufacturing into consideration. And then the last one on the same technology, and I'm going to just jump in a bit here, is another view of it in Apex. So the beta version is already available for testing if you're interested, while the general release product should be available within the next few weeks. So this is just an example of a 3D printable part directly designed by adding the Adams load cases into this part. I actually just remember now that there's another example which is actually maybe showing this a bit better, of the feature integration even with Adams car into Apex. So these are at this stage evaluation or demonstrator products. So this is not yet available in the general market, but it shows you some of the already existing post-processing capabilities within Apex that will be utilized in this environment. And of course, the beauty is that with your Adams integration, you immediately have the load cases required for structural design and optimization. So with that in mind, there's a lot that you need to know and need to be proficient with using Apex. So I'm going to import 4 models here, 4 CAD models, and we'll go through them one at a time. And as I said, if there's any questions, please feel free to add it in the Q&A session, and Moritz will consolidate them and draw them to my attention. Right, so let's start off with the Creo file. So this is a CAD file that came in and was clearly in a broken state. It is supposed to be a solid, and in the model tree it is actually registered as a solid, but there's clearly something wrong with it. As you can see, we only see the outline faces of this solid. One of the ways that I also found that this thing is definitely broken is when I attempted using the mid-surface tool on this solid, it flatly ignored me and failed. Over here at the bottom, it showed that it failed, and the reason is that it has faults. So the way we investigate what the problem possibly could be is to go to the geometry cleanup tool. And the first thing I always attempt, well, the first thing you should actually do is to use this option. But I've come accustomed to using the geometry cleanup tool first and see whether or not that fixes the problem. In this case, it actually makes the problem worse. As you can see, all of a sudden, my solid has exploded into surfaces, and these missing surfaces didn't return. So I'm going to undo this operation, and I'm going to investigate now what is wrong with this CAD file. And I'm going to use this tool shown over here. So I select the solid, middle mouse click, and lo and behold, it shows me that there's a very definite defect, being the body that is self-intersecting. And this is something that we find quite often with CAD files being imported into this environment. Somebody's saying, yes, Moritz.
There's a video issue. Someone is reporting that they're not receiving the video.
Oh, goodness. Okay. Let's stop sharing and just do this a different way. And I'll share my second screen. Okay, so let me just stop this process, because I'd like everybody to see this in action. Right, so the video is supposed to be showing now, I hope. Benya or Zak, can you just via WhatsApp quickly indicate to us that it's working? Yes. All right, so hopefully the video is working. So I'm just going to repeat the process of importing the CAD files. I'm just waiting for a confirmation on our WhatsApp line that there's indeed video showing now. And I'm just going to... Right, okay, sorry about the interruption. We can now...
Paul,
yes.
I got confirmation from various people that they see the video on their side, so I don't know if it's maybe a network issue on that specific person's side that's not seeing the video.
Okay, so the rest is seeing it, so let me continue quickly. So I'm just going to quickly repeat what I've done before, so hopefully those of you haven't seen this will see it now. So using the fault finding tool, it shows us that there's an intersecting body. In fact, it actually shows a few other things as well. Things like face missing, tessellation, etc., etc. So there's a number of problems. Now, the first thing you'll notice is that this self-intersecting body have two... I'm just going to mute you for the moment, Moritz. There's two faces over here. And the quickest method to rectify that, well, because, you know, a solid shouldn't have faces inside. So there's clearly two faces over here. And the quickest way to simply separate them from one another is using the push-pull tool. And after I've done that, immediately the solid turns into a proper solid without a defect. And all I do now to close this gap is to use the up to option over here to move that face up to the other one. And there we have a complete solid. And now my mid-surface tool should be working. And there indeed, we have a mid-surface created right at the middle of the solid, with the thickness automatically assigned. And just while we are here, I'm going to quickly show you another feature that not many people are aware of, and that is the defeaturing tool for special features like this. Now you could at any stage select them one by one to get rid of them if they are going to be a nuisance in your FEM. So let's just quickly mesh and see the effect that they do have on the mesh. And when I defeature them, they obviously improve the mesh quality by removing that level of detail. But in a model like this is going to take you quite a while. So for standard features, we have the middle option over here. And this standard feature identifies 2D holes, fillets, and chamfers. But these are neither of those features. So for this, we use the custom defeature tool, where we train the algorithm what the shape looks like that we want identified, select the surface that we want them to be identified on, middle mouse click, and now we see that all those features have been identified. Now, while they are highlighted, I can actually individually hide or deselect some of them if I want to retain that, and then middle mouse click to confirm or finish the operation. So this means that all those highlighted features will now be removed, and the ones that I unselected will remain. And there we have clean, nice geometry, except in the area where I wanted to retain the detail. And if I want more local detail over there, I can use the seeding option to specify number of elements in these areas, if this is what I required. Okay, so that's that for this example. So let's move on to the next one. And I think it was this guy. And switch on solids again. Right, middle, left right mouse button clicks to fit view. So here I have a solid that I would like to hex mesh, but as you can see by switching on the robot, this body is indeed not hex measurable, and that's because of the detail that we have over here. Now this is detail that I'm not interested in from a structural point of view. Now normally this would be a very simple thing to defeature, and I had great difficulty in finding out why the defeaturing didn't work. I eventually found out what the reasons were, and that's what I actually want to show you, and actually show you some ideas and tools of how you can find the reasons why defeaturing may or may not work. So what I actually tried to do is purely to select all these surfaces, and I can see so I first want to select all the ones on the one side and then all the ones on the other side. So now all those surfaces are selected, and how defeaturing works, it extends all the unselected features or faces to close up the ones that we want to defeature. So if there's a logical solution, it will defeature it. So now I press the apply button and only one face has been removed. So there's clearly something amiss with this body. The question is what? Why didn't this thing work? Well, sometimes I'm a bit lazy and then I don't try to find the faults, and I just switch to other tools to try and get rid of it. And the push-pull tool with the up to option is actually quite useful in many cases to try and use. But again, this one failed as well, which is quite odd, because in normal circumstances this would most definitely work. In fact, I think it actually works on this side, if I remember correctly. Yeah. So there's clearly something wrong, not with the software or the tool, but something in the CAD on this side, because this side doesn't want to defeature at all. So let's have a look at this option again, if there's any faults that we need to know of. And the strange thing is, again, it doesn't, in this case, doesn't show us any errors. So the next logical thing to look for or to do is to simply execute a clean function and see if that actually makes any changes. And we can see that the body has been cleaned. So let's try and see if we can defeature them now by selecting all those features and just checking that everything up to the end has been selected as well. Middle mouse click, and doesn't work still. So there is clearly still something wrong, and the question is what? So then the next step was to use the next option to actually find if there aren't any small features that aren't clear. And lo and behold, there's a huge list of small little features of different types. Short edges. So let's rotate the model and see what's going on here. Aha. And I hope you can clearly see this. There is indeed a small feature that came through from the CAD product, and that is the reason why the defeaturing didn't work, because I didn't include those small faces. If I go down the list, I'll see there's a list of faces as well that falls into the small category, the same ones. And there are also some sliver elements, essentially the same ones as well. So how do we get rid of them? Well, you can, of course, now get rid of them manually by clicking them one by one. Get rid of them like this. And what the defeaturing tool then does is it extends the surrounding areas. But as you can now see, this list is quite long and it will take me quite a while. So let's just try something else and use the auto fix option. And this is where we tick on the option to fix this automatically. And now we see the list has been reduced dramatically with only a few ones remaining. Now, I don't always like the idea of software automatically fixing things because I'm not always sure where and what it has done. But when the list is that long, I'm a bit impatient. So in this case, I'm just going to click auto fix, and there we have it. And all those defects have been removed. And let's see if our defeature tool now works. So I'm just going to select all those tangent faces, middle mouse click, and gone they are. Let's see. Okay, of course, it's still not hex meshable because I didn't remove the features on this side. So let's just do those. Middle mouse click, and gone they are. And now our body is indeed hex meshable. So we can enter hex mesh mode. I think a 0.5mm mesh on the small part should be sufficient. Or it should have been 1mm, I can't recall now exactly. So let's just give it a moment to complete. There we go. All right, so now we see a nice clear hex mesh that is suitable for structural analysis. Right, and that is the end of that example. So let's see, we have about 5 minutes left. So let's have a look at the next one. And this one is a piece of CAD geometry that is affecting the mesh quite dramatically. And the reason this is happening is all those vertices that one can actually see when highlighting the vertices in this case. A quick way to get rid of these, if this is not, well, the reason here is that you can never ignore these unless you suppress them. So there's two ways. You can suppress entities like this, and now the mesh is able to ignore it, and then we can use the seed to refine the mesh again. Or another way would have been to remove all those vertices altogether. So suppressing don't remove them, it purely ignores them, while removing them actually removes them. And the reason why we would typically want to use unsuppress is, or suppress, is that then the entities are not ignored, or we have the ability to bring them back. Okay, so those are two useful functions to use. And then the last example. Okay, definitely not going to hex mesh this guy at this stage, but let me show you the reason we would want to use partitioning. Now, in the new Apex generative design, partitioning is of particular importance because that is the way that you will be applying loads to this design space body and to get it into a generative design. Partitioning is also useful when we do want to use a hex meshing in a model. For instance, and I'm not going to do the whole model, but I'm just going to show you this quick example of using the split partitioning option on a large body like this, picking two surfaces as a guide on how the structure should be split. And now we see that a portion of this solid, and it's still only a single solid, can be hex meshed. So let me just show you that that is true. I can remember the size, I think it's 20. And in this case, I'm only going to hex mesh this single partition of the solid. So 20 was a bit big. Let's make it much smaller. And you can see very nice hex mesh generated on that portion of the solid. And if the solid is suitable and you have spent some bit of time on it, you'll be able to hex mesh the remainder of this part as well. But right, that's not the actual thing that I wanted to show you. What I actually wanted to show you is a problem in this particular design. So let me just boolean those cells again. Sorry, I just want to select it like this. Okay, so we have our single solid again in a boolean operation. So what actually needs to happen in this model is that all these solids have to be boolean, but they have to be retained as cells. So we want to use these internal bodies that overlap, or not overlap, that sits inside the holes of this one. We want to boolean them using this option of booleaning them as partitions. And in this case, quite a number of them did in fact work. So we can see that a lot of these guys did in fact boolean, and they are there, but there's a remaining one that did not. So I'm going to delete these empty parts just to get rid of these empty parts in the model tree, just to show this clearer. And it took me quite a while to figure out why didn't these two boolean, because this inside bearing frame was quite important for me as a load transfer location as well. And eventually what I found, let me just switch off that. So in this rendering mode, we can actually see the two different colors, and maybe I can make it a bit clearer. What I've picked up is the rendering actually shows you or indicates to you that this area, and it's a bit difficult with this thing highlighting up, but there's an area where the shading don't, on this ridge, where the shading don't blend. And that's a giveaway that those two surfaces aren't properly aligned. So the CAD operation wasn't perfect. And I'm just going to bring those two together and then try my Boolean operation between these two bodies again. And there we have it. Now there's only a single body. Now, in this particular case, I just want to draw your attention to the fact that there was one additional defect, and that was some small slither cells that remain. So that means these two faces of those solid bodies wasn't perfectly modeled in the CAD system, and we can either then replace the one face with the other, or if you wish to just simply Boolean those cells again if you're a bit lazy, like I am most of the time. So now there's a single cell, proper cell, that you will be using for load transfer as well as hex meshing capability. So typically, once you suppress some of, let me just get through the suppress feature. If you suppress some of your functions, these bodies may become hex meshable as well. This particular one still looks like it needs a little bit of attention. I'm not sure if there's it's always a good idea to remove all the unnecessary vertices in a model. In this case, this model has removed 309 unnecessary vertices. As you can see there, a few of them that did not. So another thing that I'm not sure if everybody is aware is the ability, and I'm really going to stop now, is the other ability that's been added in the latest release, where we have vertex and edge drag for surfaces, and we didn't have it for solids. They've now introduced the ability to drag solid vertices as well. So if there's a small defect or some modification that you would like to make to a model, you now have that option. Okay, so that's the end of my presentation, and the floor is open for any questions. it looks like there's one question from Ryan, and he's asking, what is the advantage of using Apex to sort out geometry issues rather than touching up in CAD and re-importing it? The main advantage of it, Ryan, is the fact that in many cases, Apex is actually much easier to use in that regard, and you don't need to go back into your CAD environment to do the fix. Another reason is very often you only find the defects when you start meshing the model. And then you've already done so much work that you don't want to go back to CAD, fix the problem, and start all over again. The nice thing about Apex is the ability that you can mesh it and still modify the geometry. So any change that you make to your geometry, and it will probably be quicker to demonstrate it on one of the other models rather than this one, is the fact that I can make a change and I don't need to redo the mesh. So I can literally come in and use any of my normal geometry editing features, and the mesh will update along with it, as well as any loads or boundary conditions that you may have applied to these entities. This mesh is a bit fine, so it takes a little bit longer than normal. What we could do is to just quickly go in and go to the properties and change this to, let's say, a much larger mesh, which updates quicker to illustrate the point. So again, the ability to do any CAD operation with only a few tools that you need to know, and you don't have to be a CAD wizard to be able to do that. There's one more question from Edwin. He says, thanks for the video, informative, useful features for CAD cleaning. Can you switch off the highlight model feature when you hover with the mouse over a body? That is a very good question, Edwin. And the answer is twofold. It's yes and no. There is no off switch button, but what you can do is to switch to a entity type on the filter that you are not interested in selecting or highlighting. So by default, Apex changes the selecting the default selector over here to the task that you're busy with. So for instance, if we are splitting faces, by default, it's selecting faces. If we are splitting curves, by default, it's highlighting curves. So to answer your question, if you don't want the part to highlight, typically like we had in this model that we've shown over here, where I was trying to show you some defects, and the whole time this thing was, sorry, let me just get out of that tool. It was the whole time I was operating here, it was highlighting. And this is especially useful to know when you're, in this kind of view where there's no empty space to get off this. So a quick way is to simply jump into a tool where only a specific type of entity wants to be selected, like curves. And we know we're not really interested in the curves at this stage, but it frees up my mouse. And this is actually a trick that I should have used when I was showing you that other alternative method. The other way is, if you're not switching to a different tool, is to actually, simply change the selector by right-clicking anywhere. And this is the selectable items over here. So I hope that answers your question. Anonymous is asking, is it possible to pause the mesh update until all geometry updates are complete? For example, having to remove multiple vertices. There is at this stage not any way to stop it directly like the auto updating feature over here. So what you are referring to is, so if I'm busy editing geometry, the mesh will automatically update. The only workaround that I have for you in that case is, let's say, for instance, I only had this body meshed, and I want to make a CAD modification, but I don't want the mesh to update immediately. The only workaround that I have is to delete the mesh. So that would be the easiest way. Delete the mesh. Remember all your boundary conditions and loads that you've applied, even mesh seeds, all those things will remain. So by deleting the mesh, you remove the requirement for anything to update, and you can do all the CAD modifications very quickly that you want, and then you simply just remesh it with the properties that you wanted in the first place. So that's at this stage the workaround for that, and that's especially useful when it's a very large model that takes a while to remesh. So I hope that answers the question. So with that, thank you very much and see you soon.